iclimabuild. ONSYS. In the framework of the iclimabuild project, ONSYS is in charge of the development of a centralized data management system which will serve as a knowledge-sharing platform, linking materials processes characterization data, along with methodologies for effective data analytics and correlations following FAIR principles. The structure of the centralized data management system made in Grant MI for the iclimabuild project.
So I will do a quick review of the iclimabuild database from the Explorer webpage. You can come here, iclimabuild, and we have all those options, materials, test data, simulation definitions, partners, everything. I'll start showing by the materials. So here we got all the materials and their properties. And we can choose which properties appear here by just clicking here. Also, we can come here, I'll show you some test data. We come here, the same.
Bio G3D. The Bio G3D uses the 3D print technology to materialize a wide range of high-performing materials in the iclimabuild. VAT photopolymerization 3D printing system. PLA-based hybrid acoustic panels. 3D printing of preliminary ceramic components. Assembly of absorbers and passive coolers. Technology. The Technology developed the world's first fully autonomous in-situ wireless humidity sensor that is powered by thermal energy harvesting from the temperature difference between the outside and inside air of a building. The project investigated different sensor methods and found a standard humidity air sensor to be feasible for being implemented in a novel cellular lightweight concrete (CLC) insulation material developed by RISE. EureCat. The EureCat installed, connected, and set up sensors on TC2 and TC4. Building the DAQs. Connecting the sensors to the RPI. Installation of sensors on TC2 and TC4. Placing the sensors on TC4. Placing the sensors on TC4 outside. HTWK. The main goal of HTWK is the industrial pre-production of the sandwich panels, within and outside layers of TRC and CLC, for insulation. The production of this sandwich, with integrated pre-produced parts from RISE, as industrial production is an upgrade as a whole and implements the upgrading of each workstation with optimized process. 9 TC4 sandwich panels were produced for material testing and living lab installation. The production process could be tested and optimized. However, as the robotic workstations are still in programming, the production was partly handmade by HTWK Leipzig. INEGI. The INEGI created a new wall panel made of composite materials. IRS. IRS contributed to the translation of specific requirements of iclimabuild material and processes into simulation workflows. Specifically, IRS implemented AI and computer vision for the detection of defects at 3D printed thermoplastics of fused filament fabrication under iclimabuild pilot line 3. Image processing, supported by BIOG3D, was performed using a pre-trained real-time object detection algorithm with high computational speed. To identify the hazard level of the used materials, and the exposure potential of processes within iclimabuild, IRS followed the OECD approach for risk assessment. IRS focused on the in-depth assessment of the higher risk priority pilot lines, by conducting a series of on-site measurement campaigns. The assessment was completed by offline toxicological, morphological, and chemical analyses, performed by BIOG 3D. Sustainability is an important aspect of iclimabuild. To evaluate the potential environmental impacts of the project's materials and components and to facilitate environmentally friendly decision-making, IRS has performed life cycle assessment of the project's advanced building envelope materials and components produced at 9 pilot lines. ITA contributed in the area of modeling, simulation, and analysis, according to the project requirements. Tensile finite element simulations have been performed for estimating the influence of the microdefects on the mechanical response of 3D printed filaments. In the first phase, the models reproduce the geometry defects observed. In the second phase, simplified parametric model for each type of defects have been developed to observe their influence on the micromechanical response. These simulation results have been used for the building of a digital tool. This engineering digital tool was developed to calculate, in real time, how the stiffness of the filaments varies as a function of the geometrical dimensions of the microdefects. As part of the iclimabuild project, multi-scale methodologies have been developed to study the thermal and mechanical behavior of different materials and component designs, evaluating the microstructural and design effects of the components. To this end, a simulation framework has been developed that combines discrete element methods to generate the porous structure, Python scripting and geometric optimization algorithms for the discretization of 3D domains, and the finite element method for thermomechanical calculations. Discrete methods provide a good approximation of the porous microstructure of materials, such as aerogel and lightweight cellular concrete, and the modeling of the mesostructure of composite materials, in which air bubbles and additives are present. 3D Voronoi models are the basis on which the solid skeletons of each material are formed. To that end, where geometric algorithms are used to approximate the network structure of the silica chains of the aerogel or the lattice structure of the cellular lightweight concrete. Then, simulation methods, such as finite element analysis, are used to analyze the effect of these microstructures on the insulating behavior of the material. Likewise, the effect of changes in the configuration of the fabrics, such as the diameter of the fibers of the textile reinforced concrete, or the arrangement of the fiber bundles, on the thermomechanical response of the fabric is addressed. Finally, all data recorded about the effect of the microstructure and the configuration of the materials is incorporated to the panel design process via a parametric approach. This simulation model also allows to vary design factors, such as the dimensions, the thickness of each layer or the spacing between connectors, for evaluating their effect on the insulation properties of the panel, or more importantly, its role and impact at the building level. Simulations of manufacturing processes have been carried out. In this case, a comparison is shown between the flow front advance obtained experimentally and in simulation for a Vari process. Polito. Polytechnic, University of Turin, installed and tested the new technology materials developed during the iclimabuild project. Roof of the Polytechnic University of Turin, during the handling of TC1 for installation on the twin. Exterior view of the twin, after the TC1 and instrumentation were installed. Instrument installed in the TEEB L2AB for pretest, for assessing environmental quality before the installation of TCs. TEEB L2AB during demolition of existing transparent envelope technology. Detail of the fan of TC1 before assembling the device. Installation of TC1 inside the frame. TEEB L2AB during the final stages of facade component installation. Electrical box during thermocouple calibration. Wiring of electrical panels and instrumentation installed in the TEEB, L2AB. TEEB, L2AB after installation of measurement instrumentation. TEEB, L2AB after finishing and covering cables. Final status of TEEB, L2AB ready for occupant entry. Exterior view of the TEEB, L2AB facade after installation of TCs, compared with the previously present technology. RISE. RISE, within the iclimabuild project, is involved in the development and production of cellular lightweight concrete as insulating material. Creation of composite foamed concrete element. Density check. Insulation process. Shrinkage check. Block preparation. Rubitherm. The Rubitherm installed the in-house monitoring test bench for testing PCM systems validated by the RAL Quality Association PCM.